Hello and welcome to this week's What Were They Thinking? Among the many items to be discussed in this video, we have updates on the various vaccines that are available for the CCP virus, some rather entertaining takes on exactly what people think about the various viruses and things out there, hiccups with different developments in technology, and advantages and success where others have seen failure. We'll start with an update on the Pfizer vaccine. The Pfizer vaccine at the moment is one of the more popular. It has slightly fewer side effects, but at the start was generally not preferred due to the complications surrounding its transport and use. It was generally thought that it needed to be kept at incredibly cold temperatures. In order for this to be possible, you needed to have specialized equipment, freezers that could operate at temperatures below -60 degrees Celsius. Yet another country's regulators, Australia this time, has approved the storage of Pfizer, this time at a regular fridge temperature. This means that the vaccine can be stored and transported to a vast number of places where previously it wasn't possible. The important caveat to this is that you can store it in a regular fridge for up to 5 days, and at a normal freezer temperature for 2 weeks. This will drastically enhance the ability to transport and deploy the vaccine to countries that have a less developed infrastructure and logistics system. In other vaccine-related news, the Johnson & Johnson vaccine has been halted in America. This follows incidents of clotting, the same sort of rare blood clotting disorder that has been seen in other countries. 6 women in total between the ages of 18 and 48 developed this. It all occurred within 1 and 3 weeks of vaccination. 1 has died and 1 is in critical condition in hospital. The other 4 appear to have largely recovered unharmed. This is 6 incidents out of 7 million people, an incidence rate of less than 1%. The FDA has not recommended this lightly, but they also state that they are doing so out of an abundance of caution, rather than observing that there is a significant issue with it. This has also been phrased as a recommendation rather than a rule. The concern with this is twofold. 1, whether or not the announcement and the various controversies around it are a means of promoting vaccine hesitancy. It's creating public disconcern about the veracity, validity, and safety of vaccines where, arguably, there isn't one. If people were to take the vaccine in a setting such as a hospital, if they are concerned about the vaccination and possible blood clots, then the issues at hand are largely mitigated. The second issue relates to whether or not there will be enough vaccines available as a dose for America, and particularly under the Biden administration's claim that by the end of the month they plan to have enough doses of any vaccine available that every American can have access if they so wish. Arguably, this is a case of America taking, or at least America's government, taking a step towards transparency, something that is arguably not as common as you might want. There is an interesting observation. There are currently 4 vaccines that have approval in America. You have the AstraZeneca and you have the Johnson & Johnson. These are based on similar technologies. Then you have the Pfizer and Moderna vaccines, which are based on similar technology, but different from that which is currently causing blood clots. It would appear that, at least in theory, if there is concern about safety, that there is a very simple and direct answer. If you're concerned about blood clots, don't take the Johnson & Johnson or the AstraZeneca. Instead, go with the Pfizer or Moderna vaccine. This is simply because there's been no recorded incidents of the same kind with these other vaccines. This means, at least in theory at this stage, they are safe. This is something being seen with Australia. Australia was planning to purchase a much larger quantity of the AstraZeneca vaccine. This was slightly modified, let's say, New medical advice recommended that those under 50 instead be given the Pfizer vaccine. This owed to the issues around blood clots and data that indicated that there was a likely relationship between certain age groups and the blood clot disorder. Australia was looking at a variety of suppliers to get this available. Pfizer and AstraZeneca are the first two. The next is Novavax. Novavax is known for making the influenza vaccine and insulin, but they also have a raft of other drugs that they make. The Pfizer and AstraZeneca vaccines are somewhat different to the Novavax vaccine, which contains the spike protein, same as the virus that is infecting everyone. This allows for a more direct ability to detect and know what virus the immune system needs to handle. This is very similar to the influenza vaccine. If Australia follows this particular process, then that means they will have 3 different vaccines using 3 different methods to activate the immune system available. This will largely remove many of the issues seen with particular vaccines with particular people. Most vaccines have somewhere between a 90 and 95% efficacy, with slight variations on each side of that. This means Australia is looking to have the vast majority of its population completely covered. Fortunately for Australia, the vast majority of its population is already largely protected because they've pretty much entirely eliminated the CCP virus from that country. Australia, much like New Zealand, has largely seen success through public health control measures and more. A public health control measure that's becoming controversial in a manner of speaking is a vaccination card. We spoke somewhat about these last week with the idea of having a vaccination passport. The article in question from Healthline explains why it's a good idea to keep your copy of this vaccine card on hand. Going forward, it could be very useful and a lot quicker to have a copy, whether as a photo or the original, in order to be able to travel and do other things. The article explains a series of reasons why it would be good to have a copy, even if we're not talking about something like travel. For example, if you have an adverse event, knowing not only which vaccine, but what batch of the vaccine you received could be useful information, especially if we're looking retrospectively at any adverse events that could have consistency amongst the entire population that received them. For example, Johnson & Johnson had to recently destroy a large number of doses of their vaccine because it had been contaminated. If that had gone out into the public and been used, knowing that that batch was at fault would have been incredibly powerful information. Then there's if you possibly need to get a booster, and a number of other factors that would be easily understood, identified, and known if you simply had a copy of your immunization card on hand. While still on the topic of the CCP virus, we should look at just how effective vaccines are at preventing infection. At the moment, approximately 565,000 people in the USA have died from the CCP virus. Just over 31.5 million have been infected. Of those who have been vaccinated, 0.008% have caught COVID-19. That is, of the 75 million people who have been completely vaccinated, 5,800 had a positive test for the CCP virus. A fraction of these had to be hospitalized, and an even smaller fraction, 1.3%, died. It's worth remembering that in many cases, at least in theory, the vaccine should prevent severe cases of infection, but not everybody has the same kind of response to vaccinations. This is why not everyone, despite receiving the annual influenza shot, will have the same degree of protection. Some people will still get extremely sick. It takes away the worst of the disease for the vast majority of the population and reduces the duration and severity for the remainder. It's worth noting that 40% of these infections leading to death were amongst those who were over 60. This was already the group that was at greatest risk and already represented some of the largest percentages of the population that has died due to infection by the CCP virus. The fact we've brought that number down slightly is a significant improvement. These sorts of milestones have been achieved without having to yet account, for the most part, for different strains of the CCP virus. There are currently 3 that are concerned: the UK variant, the South African variant, and now the Brazil variant. The Brazil variant is newer than the others. The concerns with this are, 1, that it is more contagious, and that it can reinfect people who have already been infected by the strain of the CCP virus that came from China. The Brazil variant has proven to be problematic because it's mutated, and the mutation it has is what is letting it dodge the immune system in our bodies. The virus spike protein that we've already mentioned for some of the vaccines has been changed in this new variant. That is what lets it avoid the immune system. It's one of those things like a flag that tells the immune system that's what it is. When you change the flag or the sign on it, the immune system no longer recognizes it as the same pathogen and therefore doesn't try to deal with it in the same way. In fact, it has to start from the beginning all over again. Despite this, at least insofar as the Pfizer and AstraZeneca vaccines are concerned, they appear to still have some efficacy against this new variant. Unfortunately, there's also evidence that some of the other vaccines are less effective. This will be even more important now that there are 2 more variants of the Brazil strain, particularly the P2 and P4. Both of these have only just been discovered, and it's unclear whether or not there is a higher mortality and even a higher incidence of infection with these new strains. There was an interesting article from Politico, and it looked at one simple thing, that particularly among Indian American nations, the infection rate has basically fallen flat, or as flat as they can get at the minute. This compares incredibly favorably when you look at places like Brazil and even large parts of America. The incidence in those places has skyrocketed. The article, in short, was looking at just why exactly the Navajo Nation, as an example in this, has basically managed to supersede America as a whole, both in its vaccination rates and suppression of the virus. We suggest looking at this simply to get a different perspective on how the vaccines and control of the virus's spread have been handled. This is notably of more importance in a healthcare setting than it is at a state level. Healthcare centers, such as hospitals, could, at least in theory, act as a hub to spread the CCP virus. If you have a healthcare worker who seems to otherwise be healthy, picks up the virus, and they could then spread it without being aware of what they're doing. This is why frontline healthcare workers have been at the very front of most lists for vaccination. Whether or not it works for them has been the question. Studies published in the New England Journal of Medicine have given a lot of evidence to support the idea that vaccination healthcare workers is an incredibly effective and efficient means of curtailing the spread to a degree, but it also protects the medical system to ensure it has continued functionality. To summarize the findings, in the second week after the second dose was given of either the Pfizer or the Moderna vaccine, there was a 0.2% infection rate. There was a 0.05% infection rate, and there was a 0% infection rate among 3 different medical service areas. Well, technically 4, as one study looked at 2 medical service areas with just under 37,000 employees, the second had just over 23,000, and the fourth does not state their numbers. Looking at this, you could expect that there'd be somewhere between a 0.05 and maybe a 1% infection rate at the high end. In the general population of America, the infection rate is currently closer to 10% of everyone. Going now from the controversy of the CCP virus to a frankly bizarre case study. Involves a baby boy. A baby boy who was born with 3 penises He had 3 penises formed during embryonic development and is from Iraq. Naturally, unlike in some insects, 2 of these were unnecessary and were removed. This is an otherwise incredibly rare congenital condition and occurs only once in every several million births. They will differ in size and sometimes location in different individuals. In other news related to children, but this time less a case study and more an interesting event, a family was able to get millions of dollars in order to provide their child with experimental gene therapy. Gene therapy is something we've mentioned already in several different ways in other videos. Notably, there was the incident of Dr. He, who genetically modified embryos to be HIV resistant, and failed. Then there were other issues in other times with something like mRNA technology being used for heart disease in Japan. The gene therapy in this case was for something called Canavan disease. It's an inherited brain disorder and it will eventually lead to death. In order to get this gene therapy, not only did they have to fund the research themselves, but they had to then travel a long ways and undergo a very invasive treatment and in the form of surgery, which allowed them to insert the virus particles carrying the right gene in the right places. This has taken 4 years. The unfortunate thing to this is not that it's going to cure the children of their condition. Rather, it's going to prevent them from progressively getting worse. That's the middle ground. There is some hope for a small amount of recovery. That is, they might find some of their brain function can resume. The unfortunately more likely downside is that there will be no improvement and no recovery. Many clinical trials like this have a very high failure rate. Going now from somewhat controversial gene therapy in humans to treat a disorder, instead to rather controversial chimeras. These are made from humans and monkeys. Yeah. This is perhaps why science occasionally gets a bad rap. The chimeric combination of a human and monkey was intended to create a living embryo that would never be possible using normal methodologies. There are many ethical and bureaucratic issues with embryonic research. Some of these can be circumvented by using animal-based research. The problem with this is that animal research can quite frequently not translate very well to human-based research. This is where the chimera comes in. There's research that's already established showing that you can grow a human organ in a pig, that this can then be transplanted to a host who can then use it. The idea with this research then is slightly reversed. We take a human-type embryo and a monkey embryo and see whether or not we can grow differing organs in each. This then developed into the current chimera. Having either human organs or whatever it is you happen to be looking at in the embryo means you can find human data that should translate more or less exactly from the research model to human clinical trial models. One of the big handicaps to this study is that it still has a relatively high attrition rate. Of the initial 132 embryos that were successfully integrated, 103 were still alive and developing at 10 days, approximately a 30% fatality rate. Then you have to consider the issues of how many embryos they started with at the very beginning. Finally, how many remained after just 19 days. At day 19, 3 of the chimeras were alive. This research is also especially contentious for one other reason. It is possible that it's being conducted in China because China's regulatory systems aren't as robust, let's say, as those in Spain where the research originates from. And the argument is that they're doing it in China for exactly this reason. it allows them to get around legal issues. The response has been that, at least in their opinion, Spain lacks the necessary infrastructure to run the experiments. Spain does have a fairly well-established genetics research body, and the argument, without exact details as to what they needed and what wasn't available, doesn't sound as compelling. While still in Spain, we need to look at DNA that's been extracted from dirt. Neanderthal DNA that has been extracted by dirt. The fossilized remains were able to be isolated and processed in such a way that they could get DNA from 100 millennia ago, and that's not an easy thing to do. The technique is unfortunately destructive in that in order to get the DNA, you need to destroy part of the skeletal material that you have. This does, however, provide a lot more information, and you can either extract bone material that has been left in the ground, either when someone has been buried or died. You can also find small traces in things like skin and other material that is in the soil around it, if it has been preserved. Although there were many findings from this, one was that there was effectively migrations over several thousand years in which you would find different genetically distinct groups would move in and take over while still being Neanderthals, and that this is effectively repopulating the area or replacing the population that was there. Going now from genetics to a combination of physics and engineering, the creation of light that can pass through an opaque material. Generally speaking, it's accepted that opaque material is generally not going to cooperate with light, that as the light hits it, it's scattered, and this prevents it from moving through. University researchers from TUEN in Vienna and Utrecht University in the Netherlands have been able to create a light that is able to pass through. This uses particular light waves, and they get through the disordered medium of something that is opaque, such as sugar. This works by simply being delayed, not necessarily stopped, as is the case with most light that hits a material like this. Although not immediately applicable to a large number of things, the knowledge could be incredibly useful in the reasonably distant future. Whether you're looking at passing signals through otherwise opaque material, for example, our atmosphere, which is resistant to most light getting back out again, and other situations such as trying to shine a light into a specific place, for example, in biological studies. All of these things could work extremely well if this technology is developed enough. Next is largely a feel-good story, although the content of it is interesting. It's about a student who, only in their second year of university, has been able to modify an existing code and, in doing so, contribute significantly to quantum computing. What they've done is look at a particular code that's been studied for more than 20 years as part of their homework. The idea was to study it and respond. Well, they looked at it, and by tweaking just a few variables, suddenly they're able to start getting a lot of error correcting that wasn't there before. Error correcting that could be incredibly useful in chips that are widely used, as it improves their performance by a large margin. As with most of the code that's best, it's a small change, a small bit of code that doesn't overly clog up the system and make it difficult and unwieldy to use. That means that it can have disproportionate impact. As one of the academics involved in using it states, what amazes me about this new code is its sheer elegance. What is not so elegant is the next point we have to talk about, and that's Starlink. Starlink is creating more and more issues for astronomers, and you can see them just here. This is what they're not happy about. People who are trying to take photographs of the night sky or trying to study it are having a lot of problems with this new effort by Elon Musk. They're bright, they're obvious, and they interfere. That image in question shows about 60 of them, 60 of the roughly 1,200 that are now orbiting Earth. The plan is to send many more, up to 30,000 for the initial project. Increasing the number by a factor of nearly 30 is going to create problems, but it's also going to deliver faster internet. And some countries are already starting to see the benefit of this, including Australia. Australians are involved in what is currently a beta test of just how effective the system is. Existing data from the northern United States of America and southern parts of Canada indicate that they can get about 100 megabytes per second. In Australia, this appears to be about equivalent to some of their top-tier plans. In a country notorious for its poor internet service, something like this that is independent of the government-run networks and even the private company networks is a considerable improvement, and in a country that is particularly spread out outside of major metropolitan centers, it's even more important. We then need to talk about the fact that Starlink plans to expand its network. First, by adding a large number of satellites. This will firstly allow for better connections to more satellites and remove most, if not all, of the issues having to do with connections. Second, they have stated that, at least in the US, customers should expect speeds of between 50 and 150 megabytes a second, and that may go up to 300 megabytes per second. All of this is incredibly promising. The problem is, Starlink is not designed and built for Australian conditions. It's a country notorious for, well, let's say, a very harsh environment, where just about everything tries to kill you. While the animals aren't all going to be a problem, with there being some notable exceptions, the environment might be. The summers in Australia get incredibly hot, and that's one issue. The second is wind and fire. Both of these are pretty bad in Australia, and the heat from the just weather in general could be enough to damage or destroy these satellite receiver and transmitter dishes. The fire itself could also be another issue. Will smoke get in the way of the signal going to the satellites? In other space-related news, you have SpaceX deploying their satellites, and rockets, and a variety of other things. You also have competition, particularly from Jeff Bezos, rather famous for having effectively founded Amazon and still owning a very large portion of it. He has a lot of money to throw around. One of the things he's investing in is a rocket project of his own. This is called the New Shepard rocket. The project here is called Blue Origin, and it's a rocket intended to both launch people and cargo into space. It contains a capsule and a reusable rocket, much like SpaceX has. Of the two options at the moment, we would choose Jeff Bezos' rocket simply because, unlike SpaceX, there haven't been any unexplained mystery or consistent fires on any of their craft, but they have landed successfully, which demonstrates a safe and effective process. Finally, we go back to talking about Elon Musk, but for very different reasons. Rather than being the wide-sweeping space, we want to talk about the wide expanse of the mind and the fact that he has a controversial project called the Neuralink. With this, he plans to implant human brain chips. This was meant to be a sort of brain-computer interface, a way to have the human mind interact with a way that didn't require going through the human body. You can see why this might be controversial. In order for it to be as successful as it is and proven in order to then go through the various approvals needed, they've had to have animal testing. And one of these was a monkey that could play video games with only its mind because of the chip implanted. Exactly when and how they might move on to more advanced clinical trials is unclear, but at this moment, the fact that they've achieved as much as they have is both really cool and really disconcerting. that's all the news we have for you this week. Thank you for watching. If you have found it interesting, consider liking, sharing, and subscribing. And please post any comments, questions, or suggestions that you have below.